This lesson is on solving equations, two equations, and two unknowns by substitution. You can always graph lines and figure out where they meet, but sometimes they might meet at 100.5, 72.9. So we need some algebraic ways to help us solve these systems. So here's the first one. This method is really used mostly when one variable is solved in terms of the other. So let's look at the first one. This is the most basic. I have two equations, but I already know that x always has to equal -6 if it's going to run through that line. So I already immediately have the x value of the ordered pair. Now what I'm going to do is I'm going to take this -6 and substitute it into the first equation and then solve for y. So 2x plus 3y equals 12. So I'm going to pop in -6 for x. This will be -12. I'm going to add 12 to both sides. 3y is equal to 24. Y is equal to 8. So the point at which both of these lines meet is -6, 8. So now let's do another example. Solve the system by substitution and state if the system has one solution, no solutions, or an infinite number of solutions. And then we'll talk about that later. So in this case, I'm solved for y is equal to 3x minus 8. So in this case, I don't have either one of those. So what I'm going to do is, see how I have 2x minus 5y equals 1? I'm going to take this expression, which I know is equal to y, and substitute it into y in that first equation. Solve for x. 2x minus 5y, 3x take away 8 equals 1. Distribute through that -5. Be careful of your signs. So -5 times 3 is a -15x, and -5 times a -8 is a positive 40. Combine like terms on a side. Subtract 40. Great. Divide by -13, so x is equal to 3. Now we know that the x value of the point where these two lines meet is 3. Now we just have to find the y value. And we do that by going up to one of the two equations. It really doesn't matter which one, but this second equation is very conveniently solved for y, so we're going to use that one. So y is equal to 3 times 3, which is what we got for x, take away 8, 9 take away 8, so y is 1. So this system has one solution. Remember, when a system has one solution, the system is called consistent. So the system is consistent. And the solution is 3, 1. Let's take a look at this one. Now this one, neither one of the variables is solved for, like y is equal to 7x plus 2 or whatever. So we have to do that first in order to use substitution. And I'm going to use this guy because I think he'll be easier because I just have a -y here. So what I'm going to do is take that 3x minus y equals -23, bring the y guy over, and the negative 23 over to the other side. So y is going to equal 3x plus 23. Opposite signs moving. Y is equal to 3x plus 23. So now what we're going to do is we're going to take 3x plus 23 and substitute it in for y into the second equation. Solve for x, get the y value, be all hunky-dory. So 2x plus 3y is equal to 14. Again, that's where I'm popping 3 times 3x plus 23. A lot of algebra, but you can do this. So 2x plus 9x plus 69 is equal to 14. Then 11x plus 69 is equal to 14. Take away 69. And when I go to subtract, I will get negative 55. So x is equal to a negative 5. So I got my first guy. Yay! Perfect. Now I just have to figure out what y is. And I can use either one of these original equations. 3x take away y is equal to negative 23. Doesn't matter which one I use, but I'm going to use this one. 3 times negative 5 minus y equals negative 23. I'm trying to be really careful about everything. So negative y is equal to negative 8. Y is equal to 8. So 5 comma 8 is the solution to the system. We always want to make sure that we check it, even if it's just a quick mental check in our minds, to make sure that this point with the x value of negative 5 and the y value of 8 will work in both of these equations. I'll just check the second one. 2x plus 3y is equal to 14. This is a half check. The other half would be you would have to check the other equation. So 2 times negative 5 plus 3 times 8 equals 14. You betcha. And that checks. Because in my mind, a lot of times I do like a little mini check. So this system has one solution, and it's called, it's a consistent system. Now, this next example is really kind of cool because the second equation is already solved in terms of x. Y is in terms of x. So we're going to plug it in. Distribute, being super careful. Okay, we get 6 is equal to 6. That means that this equation that we just solved for x, x can be anything because I end up with a true statement without x in it. So x can be anything. So let's think about what y could be. Let's say I chose x to be 5, then y would be 5 take away 2 would be 3. So any relationship that connects the x and y appropriately will be a solution. In fact, if I do 5, 3, if I plug in 5 for x and 3 for y, the first equation will also hold true. If, let's say, I do 1, negative 1, will that hold true? Yes, if I check it in both equations. So there, the upshot of the deal is that there is an infinite number of solutions. So what does that mean graphically? Graphically, it means that they are the same line. Good? And that also means that the system is called dependent. Now let's take a look at this one. We want to solve it by substitution, you guys, and neither one of these lines are solved for y or x, so this second one's easier. So let's just move that 3x over to the other side as a negative 3x. And now I'm golden to go, 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 right? I'm going to put negative 3x plus 8 in for y. Do the little algebra that we have to do. We'll get 12x minus 12x plus 32 is equal to 24. Uh-oh. We'll get 32 is equal to 24. So it's false. So that means that there is no solution. Also, the lines on a graph would be parallel. And last but not least, the system is inconsistent. So if your assignment asks you any of these questions, you'll be able to address each one if you need to. Now you can go on and do this assignment. Good luck and stay strong.